And so why does that matter? This is experiential based, right? Because what you see in an engineering blueprint or a process where you roadmark from A to B to C to D sometimes doesn't stand the test of reality.
Thousands of companies show up to sell their technology to the U.S. Department of Defense each year. But so few will transition from proof of concept to true production across the valley of death. The select few who do, their stories are rarely told. Until now. I'm Noah Scheinbaum, and this is Crossing the Valley. When we first started Crossing the Valley, we wanted to tell stories about how the U.S. government could collaborate with private sector to get important capabilities out of the lab and into production. This week's episode is the perfect example of just that. My guest today is Emmy Probasco, a senior fellow at Georgetown's Center for Security and Emerging Technology, CSET, who just produced a special report titled Building the Tech Coalition. Emmy's report dives into the initiative known as Project Maven, or the Algorithmic Warfare Cross-Functional Team, and how industry, bureaucracy, and the military itself piloted some of the first artificial intelligence applications for defense. Now, Maven is a famously controversial program. Back in 2018, thousands of Google employees signed a letter to CEO Sundar Pichai protesting the company's role in the program. In the wake of that, many defense tech startups actually were formed as a reaction against that Google protest. Emmy's report and today's episode tells the story of those who remained involved in the program and the ways in which Maven has changed the game for the men and women doing the mission of national defense. I'm also joined today by U.S. Army Colonel Joe O'Callaghan, the Fire Support Coordinator for the 18th Airborne Corps and the leader of its AI targeting efforts. Our conversation with Emmy and with Joe goes deep into how this initiative came about, how it worked, for industry and for the government, and why this example of cross-sector collaboration is one to watch and potentially even to emulate for software programs into the future. I'm excited to hear what you think. Maven is still not without its controversy, so let me know in the comments or shoot me a note. Enjoy the episode. All right, well, I am thrilled today. We have Emmy Probasco from CSET, Joe O'Callaghan from the 18th Airborne. It is so great to have you both here to talk about what I think has been one of the most interesting, novel, and probably important programs that DoD has been working on over almost a decade now, right? Which is Project Maven. So what is Project Maven?
Really? So Project Maven was a program initially stood up by Secretary Work back in about the 2017 timeframe. And at that point, the program focused on how do we use emerging technologies and specifically artificial intelligence to drive down the cost of production, exploitation, dissemination of information that was gained from the use of drones, using a colloquial term. We call them UAS or RPAs in Afghanistan and Iraq. What was happening was about 10 to 11% of what was actually being absorbed by those drones in the terms of imagery was able to be exploited and people able to figure out what was there. And so the question was, how would you be able to use what was emerging in industry in the sense of computer vision to go over all these thousands, or really hundreds of thousands of hours of imagery to determine what was in play? That program started in about 16, 17 and kind of augured along and really started getting into distributed architecture. How do you do this? Analysis of all this information would require us to go to cloud in DoD. And so how did you use the cloud and build an environment where computer vision could be employed to make sense of this imagery? And we got our hands on it in about 2020 timeframe. Under, at the time, the commander of the 18th Airborne Corps was General Michael Eric Kurilla. And he's now the central commander, CENTCOM, where he's brought Maven down there. Now, I want to mark it at that point. Maven is really a constellation of about 30 different companies' technologies. This is everything from Microsoft to Amazon to Sierra Nevada to Palantir to Amazon Web Services. And all these different components were brought together by a cross-functional team under INS, or Office of the Undersecretary of Defense for Intelligence and Security. And so that's where Project Maven hung its hat. And it was under Colonel Drew Kokor, who's now retired and works for JP Morgan. But essentially, it was bringing together this architecture with computer vision capability and then using it to come up with what they were actually looking at. We took it a step further.
And Joe, what was Maven's relationship to your unit, the 18th Airborne Corps?
when we got in an 18th Airborne Corps, we were like, well, that's interesting, but not compelling, because we thought that drones would not have a long lifespan in modern large-scale combat operations. But we asked, could you turn this and use other information? Could you use information from social media? And the answer is yes. And so we started bringing that together. But what happened was we hit a nexus in about the June timeframe of 2020, because you could bring the information together, determine what something was there, and then the question was, and then what? Why are we doing this? And at that point, it was, okay, could we turn this into a decision? Could we get that information that was being brought together for that production, exploitation, dissemination? And could we, once we understood what we were looking at, could we make a decision to engage it or not?
What do you think set Maven apart from how past projects or past engineering efforts had been done?
There are two approaches to engineering. One is top down. You assess a gap out there historically. The DoD will say, hey, I have a gap here, or I have a gap there. They'll go to their generating force, in case like Army Futures Command or something like that in our case. And then it would go out from there to industry, and industry would bid and come back with their concepts. You've seen the glossy one sliders from the big names of how they could solve the problem. But with what INS had already done with building this Maven ecosphere, we grasped onto it from an engineering perspective, not from an engineering, but an experience perspective. And we said, well, we have to deliver a decision for the commander. Okay, well, what allows us to do that? Okay, cross-tack data links do. Okay, let's integrate the data link. And so then we brought in a company from Sierra Nevada. And what really allowed that to happen was the broad agency announcements, or BAAs, that INS was using. And so from a contract vehicle perspective, they had this vehicle out there that allowed us rapidly to go to different industry partners, do a quick down select between them, and pull them in. And so we looked at several different companies for data links, and Sierra Nevada was brought in as an example, brought them in, and now integrated them immediately into Maven. That was the first of many other companies to come in. That allowed us to do the initial vetting and understanding that we could do this. But what was fascinating was really it was almost more of a partnership, because what you're doing is you're not issuing out a proposal to industry and industry coming back and saying what they can do and then doing soldier touch points. Your touch point was at the point of integration, see if it succeeded or not. So what you all of a sudden had were engineers from AWS, Palantir, Sierra Nevada sitting next to each other about how do we make this work with the user. And all of a sudden, what would historically have taken maybe about a year, we were able to do in 2 weeks.
Emmy, let's bring you in here. As an outsider, how do you frame up kind of what Maven was and what it is today?
From my perspective, what I saw was Maven starts out as an intelligence, and this is notion of kind of going through intelligence, especially from drones. What Joe and his team start to do is say, hey, it's not just about the intelligence, it's about the operations. And artillery fires exists right at that intersection between intelligence and operations. So they bring it together, that sort of the AI to help you identify what you were trying to find in the needle, the needle in the haystack in terms of data. But the other important element that I saw, and Joe, you can correct me if I'm wrong, is there's a workflow element. So Joe and the artillery team have a very well-established workflow, and they develop software, and this is where the UI UX that people like Palantir were creating helps them move from just, hey, I've got all of these different intel sources and I have all of these ways of curating that intelligence, but now I can transition it through a process to make the decision that I need to make. That happens through this, as Joe said, sitting side by side with the developer so that everybody understands this is the need and this is the technical capability. But you needed that intersection to get to a decision. So I think like Maven was great, and there was a lot of good stuff going on with Maven, but Joe brings it into a new realm because he connects it through a workflow to a decision.
Joe, how do you think about integrating new technology with your team's workflows?
Yeah, Emmy, you're exactly right. And that what we said, that experience-based approach is experience equals the workflow. And so exactly to Emmy's point, what happened was by elevating the workflow and turning that over to commercial industry of, hey, you need to enact that through that constant touch point. That's what allowed us to start seeing those marked gains very rapidly. The users were able to define exactly what they needed. Industry looked at it, and industry began that immediate integration of that capability. And what that led to was, in the case of Palantir software, really began a revolution. And what that revolution is to a concept we call object-based production. Now, interestingly enough, organizations like National Geospatial Intelligence Agency cracked this nut in 2012. And what that basically was is we'll create a data object in the cloud, and then we'll hydrate that data object with information predicated on different workflows, and then reveal that so it can be democratized to different systems. And so that ability allowed us to then start intersecting other workflows and other information into these data objects. And it was really critical from an industry perspective because this had not been done before in a manner that was not given to, say, one prime or the other. This allowed multiple different companies to come in and contribute the best of what they had. In the world of data, one of the revolutions ongoing out in the DoD is open source information, right? Stuff that you pull off the internet. We call it commercially available information or publicly available information. And so you had companies like Maxar now being brought in, and that provided a nexus between NRO, the National Reconnaissance Office's expanded electro-optical commercial layer, which has multiple commercial vendors now wanting to bring their product into the system. And so now we're delivering from Maxar. Now we're delivering from Capella, information and services, GeoInt, but also just information now streaming in to this platform. And because you had built it in the cloud and had it on this backbone, you had the ability to go to expanded compute, something that DoD really hadn't done before. Because what you've seen traditionally in DoD, you would tie your software layer to a hardware layer. But this was totally different. This was software sitting in the ether, right, in the cloud, that was able to expand against compute or retract against compute about predicated on what was necessary. That plastic environment allowed us to greatly enhance what was in the realm of the possible. So instead of having to wait 4 or 5 decision cycles through a milestone A, B, and C process, what we were actually able to do was immediately flip a switch, fund the use of greater compute, and now expand the system's capability. And that allowed us to take in not only, classified sources, but unclassified sources of information, hydrate these data objects in the cloud, and then democratize them out to people through these tactical data links.
I think you guys just gave a phenomenal overview. So there's a lot of technology elements that you just put on the table, right? Data lakes, enriching data objects, democratization of information. That's all well and good for our tech friends. What I think is so interesting and exciting about this particular case study that y'all have done is that this is something that is the tie between the research and development and the acquisition people and a customer group, a user group, right, in terms of the 18th Airborne. And so I'm wondering if there is an example that you can walk us through of how the smart system is actually employed or was employed in an operation.
I'm going to stay out of operations because that gets really quickly into classified spaces. But what I'm going to do is I'm going to give you a surrogate for operations. And that is actually how we developed the system out. And so that's called a program called Scarlet Dragon here in 18th Airborne Corps that iterates every 90 days. And then a like program in Central Command, CENTCOM, called Scarlet Dragon Oasis. And essentially what they are is 90-day sprints in which you lay out some aspect of the workflow you want to incorporate, and you leverage technology against it with the different vendors that are capable of doing it. And what you do is for about 75, 76 days, you iterate to it. At the halfway mark, you do a data check where we have another program called 1,000 Decisions that executes against AI. I'll get back to that in a minute. But the 90-day arc essentially allows us to take a problem and rapidly execute against it for about 76 days. At the end of 76 days, it's 1 week to do a full integration to make sure every last bit of the integration is done. And then we go right into live fire with it. And when I mean live fire, in the case of targeting, because that's the sexy and seductive side of the Department of Defense, we're using live data links, we're using live aircraft, live submarines, live ships, live howitzers, and we're shooting live munitions on live data links. And so it's not sitting in some constructive environment that's virtualized, and then you're doing tests and evaluation, and then finally engage on it. No, you're actually doing it in the real world environment that you would use these capabilities with the real capability. And so why does that matter? This is experiential based, right? Because what you see in an engineering blueprint or a process where you road mark from A to B to C to D sometimes doesn't stand the test of reality. And let me give you an example of what reality looks like. Is you can say you're going to use Link 16, but what happens when you use Link 16 in a contested environment? What happens when you use Link 16 that permeates across different service cultures? Because the Army has a different interpretation than the Air Force does of how to use it. And so until you use it on those networks, you don't start seeing compatibility issues. Let me give you another example, HF radios. So HF radios are different. They are on the same waveform, and they do the same things between the Army, the Navy, and the Air Force. But the structure of the packets is different in all three services. So they don't talk to each other. And that's something that you don't see until you actually go out and try and do these things.
What actually happens during those exercises with respect to new capabilities? Is everything off the shelf? Is there customization?
Now, earlier I told you about this 90-day arc. At day 76, that really begins going into the last 14, where we have 1 week we call engineering week. That's where everything has to work together. If software or capability isn't ready to go by that Saturday night, that Sunday morning, going into that last 7-day sprint, then the capability isn't thrown out. It just goes into an audit mode, where when we go through live fire, we won't employ it. What we'll do is you're allowed to engineer your way through the problem set during live fire. And then it's rolled into the next 90 days. Now, these BAAs are critical, right? Because the BAAs are allowing these companies to come in and do this. But at the end of that time frame, typically what you can do is you can down select between 2 or 3 companies that are doing well, and then just move on with that company to the next rung or the next higher problem set. That's really important in algorithmic warfare, specifically computer vision and other capabilities like that, as opposed to saying developing a key component like a data lake.
Yeah, absolutely. So BAA, broad agency announcement, right? A vehicle to bring companies into a testing environment like this, or to bring companies in through a contractual pathway that allows for kind of future award. As we're listening to this, I'm struck by the recognition that this is a process that for a long time, right? This idea of customer or end user requirement gets parceled out to a prime contractor. And then the prime puts together a constellation of vendors to go deliver to it. Help put this in context for us. Have you seen other examples of this being done in DoD, or was this really kind of the first time that something like this happened? I'm wondering why you think, from the research you did, that it needed to be direct between these kind of small software non-traditionals and the government vice through one of these traditional prime contractors.
Yeah, I think to put it succinctly, it's software versus hardware. The primes do amazing work when you come to really complicated hardware and the systems integration that's required there. But with software, it's a completely different process. And so in the software process, you need these users to help you define the requirements. And it's extremely difficult to write requirements in the traditional way and actually get what you wanted at the end. It also, you can turn into this, much of the software that Joe is using, it's very unique to his situation, but it also isn't crazy different from commercial workflow software processes that are out there today. I've never told you this, Joe, but it reminds me of Asana sometimes, if you've ever used the just commercial Asana workflow platform. And so with this software, you can use these commercial products that just need the correct tweaking for the use case, but that tweaking has to happen side by side. It can't just be completely divorced. The other thing that why I think it had to be in this side by side kind of way, why it was so important, and Joe doesn't talk about this a lot, but it wasn't just that they developed the tech. It's that Joe redeveloped the way he did fires. And the way that we could even see this. One of the things we don't talk about in the report as much is that when you use MSS, you can kind of jump around the world. You can see how all different sorts of units might be using it. You can see their sort of the same picture, if you will, of what they're seeing. But we could see that different units were using it in different ways, putting in, different checkpoints along the process. But Joe's unit is unique. And I think that's because he spent so much time side by side with these developers, developing the ops as much as they're developing the tech. So I hope that answers your question, Noah, but I think there's the synergy that needed to exist, especially with workflow software.
So if you were to do a traditional ACT program, what you may start in year one is going to be defined in what we call key performance perimeters and key systems attributes. And you carry that through the arc of development of the program. Well, what happens when industry comes with you with a better way of doing it? And a year from now, completely flips the script with another ability that's even better than before. And so what it allowed us to do was constantly learn what industry's capable of and then explore together. Because when you start building a trust too, right? So when you're working side by side on a workflow and you're seeing what industry's turning for you, now you're having an honest, real dialogue between the two of you. And a perfect example I draw a lot of people back to was we were deployed to Europe to respond in the Ukraine and really to assure the defense of Europe. And while the 18th Airborne Corps is over in Germany, we're iterating on capability of the system and learning.
Can you give us some examples of how you worked with the companies? Who stood out?
And at one point, we brought a programmer in from Rebellion Defense. And, culturally, she was very different from the soldier, the warrant officer she was sitting next to. This is a girl with, pink hair, piercings and everything, sitting right next to a guy with a shaved head and a pressed uniform. And why I bring that up was that there was this divide, but once the talking started happening little by little by little, you started seeing an engagement and you saw trust as one person explained what they did and one person explained what they did. Well, at the end of 72 hours, this relationship was so tight between these two people that came from two different worlds that she was exposing emerging capabilities in liquid neural networks to the warrant officer who was saying, yeah, we absolutely need to go this way. And then that gave her the impetus to take this back to DC, where the company was based, and start doing development against it, and then entering into a Socratic dialogue back and forth over the course of the next few months on whether the capabilities, what was needed or not. This is what allows us, and when you go back to Ashton Carter's statements about how to use industry, this was a prime example of it. The other real big example is Palantir's program called Foundry. Foundry is a data management platform. It is not, I'll call it a traditional approach within the Department of Defense, which is pub and sub. I publish out information and you subscribe and you bring it into your system and you execute that message in a way that you see fit. It was a data management platform that allowed us to take the same technology that's being used by Pepsi, American Airlines, different companies to run these mass enterprises and essentially objectify data and then manage that data object. Very much like what I was talking about NGA had mastered in 2012. And then democratize that through a cloud instance where everybody can actually input and pull out of that data object. Just recently, a couple weeks ago, we ran a major program here called a Warfighter. It's the Army's validation exercise for 3-star headquarters. And for the first time that any of us knew of, what we started seeing was entire staffs not just looking at a map or output of a command and control system, but they were actually going in, manipulating data in a data management platform, and then pulling it out for presentation. This is really important. This isn't a guy creating a PowerPoint slide and putting it out in front of somebody to look at, but it was somebody actually manipulating data in a data management platform, enriching that data, and then sharing that data object with other people or presenting it to the commander for decision.
One of the things that's really key to this program is flexibility. And the BAA that Maven puts in place gives this team a lot of flexibility to make moves because it's all on R&D money, the good and bads there. But that actually wasn't enough flexibility for this team to do what they needed to do. And what's interesting is that you can see that ECS becomes critical to their success story. ECS is doing a lot of subs, and to their credit, they are subbing to the best of the best that they can find to meet the challenges that Joe and team are identifying. Palantir eventually becomes a co-prime with ECS, so they're both sort of filling really important functions for the team. And then the third group, just to piece together the really key contracts besides Sierra Nevada, which helps them with the communications, is the Morse Corporation, which is doing test and evaluation to help them maintain a DevSecOps cycle where Joe is able to do the development, is able to use whatever he's developed in Thousand Decisions or Scarlet Dragon. And then just to be really clear, even though we've talked a lot about all of the exercises that Joe has done, like these guys are out all the time. And it's not like they're picking up a new system every time they have to deploy. So they're using the system whenever they go out, and that's giving them a lot more. I mean, this is what makes 18th and this partnership super unique, is that you've got a super operational group that's driving requirements into the tech, as opposed to a group that doesn't get to see quite as much action as the 18th does.
Absolutely. I would love for you all to talk about a little bit about what this looked like, the companies that really succeeded on Maven versus those that you didn't go forward with using. What were some of the things that they did that kind of set them apart? Or how did they have to pivot to work in this environment versus how they might have been used to contracting elsewhere?
Yeah, no, that's a great question. What really set these companies apart, essentially, is they're what we would call the capitalist class of company. They have capital. They have that ability to work at risk internally, funding a lot of what's being done, essentially with some of it being IRAD, internal research and development funding, paired to these small amounts that are coming forward on the BAA that eventually yields opportunity, right? Once you've created a product and move forward. So the capital in those companies, these companies that hold both a commercial and government background, do very well. Additionally, the ability to park engineers with the customer was really a critical. This is that experiential based develop model, but because it's a learning aspect too. You don't have to have engineers that were prior Army or anything else like that. A lot of the kids we have culturally aren't the same as the soldiers, airmen, Marine sailors that we have here. But again, it gets back to the apex programmers, and you're going to learn from industry, but industry is going to learn from you. And so that ability to park somebody there for 30, 60, 90 days and to continue to iterate. And parking is both physical and virtual. You can, as long as you're going back and forth and you're in that constant dialogue, these companies are able to move very, very quickly and very nimbly because of the lessons being learned. The other thing is, from a business perspective, the companies that have really succeeded are the companies that aren't necessarily trying to lock somebody into a traditional vendor relationship where it becomes a program of record. They chase the sustainment tail. What they really are doing here is they're iterating more towards like an Office 365 approach. And that is really towards licenses. How do we license out a product to an organization? Now, where they run into challenge is explaining their tech. You know, one of the biggest statements about what has evolved under Project Maven is you have these, what some people say are excessive licensing costs. But when you look at the tech that's been created, and so in the case of Maven Smart System, where Palantir is a big component of it, most people don't realize that their network operations center is about 150 people behind the program. And so this 150 group of people are constantly making sure the data feeds are relevant. The hygiene is good, that they are constantly integrating into the data management platform. Well, that's 150 people you would have had to have bought in DoD personnel to do this otherwise, if you were to do it through another program, or pay another vendor to do it if you're to do it through a prime. So the companies kind of they struggle sometimes to explain components of their business case in a way that addresses both manpower and the actual capability that's being revealed. So once you start revealing that, then you start realizing, the licensing price I'm paying, not so bad for something like that. And again, that's where that Office 365 parallel analogy is good, because in Office, you don't realize that Microsoft has, hundreds of people behind it constantly working every day to tune that product and make that product good. It's not the same, because in the case of Maven, you have people developing in the background, or you're monitoring the data links for hygiene, safety, and so forth. A little different than the Office side, but it's still the same end state where you're using a contractual vehicle as a license to bring it on. And the goodness with that is as long as you set up a competitive environment within industry, then you simply run with the best horse. So it could be Palantir today, it could be C3 AI tomorrow. It depends on who is the better horse, and DoD can rapidly switch to that. Now, that's the last component of really what companies did better than others. we found that companies that would actually, believe it or not, iterate with each other did better. And what do I mean by that? In the case of computer vision algorithms, you had Amazon, you had Teledyne, you had Maxar, and you had Microsoft all in the same room working through some really tough problem sets where everybody would speak with each other and learn together. And so you had, Tim Brown and Dimitrios Koutsios sitting in that same room, two different companies, talking about the math of computer vision and explaining it. And so, well, they're not revealing their IP to each other. What they are doing is they're collaborating. They're collaborating with the users, they're collaborating with each other, and everybody wins. If you're to walk into the fire shop here in 18th Core right now, you're going to see multiple companies sitting with each other. And it defies a lot of common logic where in the past, one vendor, rules them all and either has subs or is doing it themselves. Here you've got multiple companies working together. And the companies that can do that, those are the ones that turn product that is not only better, but tends to be integrated. It's staged to move right into whatever environment you're working with. And in the 18th Core, we're the contingency core to the Department of Defense. That problem's going to come. We're going to deploy with their tech. And so they acknowledge that. So it's great for them to be ready and easy to snap link in.
Can I add just really quick?
Please.
I would summarize some of what Joe said as the companies that were participating had the money to participate. So they went at risk. They had money on hand to try some of this stuff out. They were unafraid to take risks on this program to see if whatever Joe was building was going to work out in the long run. And they were willing to learn and compete. So that sort of, they had money, unafraid to take the risk on this not being a program of record. They're willing to go in and compete and unafraid to compete. And that's got lots of advantages, but it also has disadvantages because we have to sometimes remember that these are still companies and this is still a country that is capitalism and not socialism or anything else. So we have to figure out how to understand their business models and figure out how to license with them quickly so that they can continue to help us and partner with us. Because, as much as they might be interested in helping us, at the end of the day, they have to survive as a business. So the DoD, this is a great story, but the DoD has to also look at this and say, how do we get this licensing thing down faster? How do we also make it so you don't have to have quite so much capital to be able to play in this game? And how do we telegraph to the companies that might want to come in, hey, there is a sunny side on the other side of this rainbow. Like, if you keep working at this, we are having a long-term commitment to this program. It's not just an R&D project that we're going to try out for a year and then forget about. So I think there's great pieces about the companies that participated, but not, no small companies. There aren't a lot of startups. We need to figure out other ways of getting really great tech performers in quickly and ways that work for their business.
I mean, let me ask you a follow-up on that and then I think try to close here. So it's a key point because one of the questions is the juice worth the squeeze for these companies, right? I think it's really important. Participating exercises, getting access to end users, relationships with customers, important. Have we seen out the other end of this big recurring revenue for those companies? Has the government picked winners that has allowed those business and sales teams to go back to headquarters and say, yes, from a business standpoint, put mission over here for a moment, from a business standpoint, this was a good investment?
Well, I don't have insight into anybody's P&L sheets. So I'm not sure what all we got. I can't make that kind of a comment, but I can say, Palantir's got had a major licensing deal with CDAO and Open Dagger. I'm not even going to attempt to say what Dagger stands for because, but anyways, it's this licensing idea. And it's one of the ways in which different commands are getting access to MSS. So you can see that on the other side. I think there are a lot of other companies that Joe worked with that even though I can't comment on whether or not it was, greatly remunerative to their companies, I can say that they're enormously proud of what they've done. Yeah. And they've all been kind of chatting with us after this project. So we've talked with the, ECS and SNC and Amazon, people are really proud of the work that they did. And that says to me that they're getting some value out of this that's beyond just a good feeling. They really want to understand what they did because I think they see, this goes to the end, what's coming next. They see that this is a gateway for a lot of other activity. They're really proud of what they've done and they can see that it's going to go further.
So where does this go from here? And I'm curious in two flavors. what's the applicability of, let's call it the smart system model? Is this how all software procurement ought to look for DoD? Is it limited? Can we put some left and right bounds around when this is the right model? Or do we think there's kind of meaningful change to how this happens in the future?
One of the things that we talked about in terms of licensing was the open dagger concept. And so can you use that in more ways so that different commands can start to license software? That's pretty new. That just happened this summer. So I don't know that we have settled on whether or not that's going to work. There's another vehicle, I suppose, that's developing. This is the Tradewinds vehicle. And I'm sure Joe can talk more about Tradewinds. I don't think, from what I've observed, that Tradewinds is quite where we want, is not the end state. It maybe is like a first step in a pathway. But the ability for Joe to basically have, if Apple will forgive me, an app store that allows them to say, hey, I've got Palantir's Foundry as my sort of baseline, and I've got Sierra Nevada to help me do my comms, but I need a different, algorithm for this particular use case, or I want to change my workflow, or I want to integrate this new data. How do I very quickly identify the app that's going to suit me best and get it into my system and start to use it? I think that's the idea for Tradewinds. I don't know that we are there yet, because I think those are still, my read of what they've done so far is more they're each individual standalone kinds of products, as opposed to being able to integrate and hold the same way that you would expect. Like, the way that your Apple iPhone is able to track your health, and then you can convert over to MyFitnessPal to track your nutrition, and then integrate all of that together for zone tracking. Like, that is not where we are at yet, but it is certainly where I think it would be nice to be.
So Emmy's kind of displayed the vehicles that are out there that are coming about. And now you've got Maven Smart System as a program of record under NGA, which means you've got the security perimeter, the contracting, everything's ready to go to support this. So between CDAO and NGA, you have this perfect nexus built. The question is, will we as a Department of Defense be able to break from traditional acquisition on software and going back to Emmy's earlier statement about software is different than, say, building a tank or a howitzer, right? Where the traditional primes and the methodology is super sound and necessary. Will we be able to make that jump, and will we be funded for it? And so one of the things that people don't really realize right now, as an example of Maven, is NGA is taking it out of Hyde. A significant amount of their funding that would go to other programs are having to divert to Maven, because Maven is producing significantly for the Department of Defense. And so how do we increase the funding to enable these BAAs under people like CDAO, under NGA? How do we fund Open Dagger in other tools that aren't traditional in means? And so as we go into the next NDAA, it would be nice to see something brought out, the 900 section or something, saying what the methodology would be to fund these programs, such as Open Dagger, to get some of these smaller companies with exquisite, amazing tech into the capability, and at the same time allow NGA, because Maven is scaled, right? So when we started Maven, you're only talking about 50 to 100 users. Now you're north of 3,000 on it at any given time. How do you scale and provide the funding for the backbone of this and to continue to do their iterations? And then what's the new jet fuel? The new jet fuel, when you buy a plane or you get a Humvee, you're going to have to use a consumable, and that consumable is fuel. Well, in the world of data-centric warfare, that fuel is called compute. And so we're going to have to figure our way about how do we budget compute for the services, because that's something that everybody's wrestling with right now.
Fantastic. Emmy, Joe, one, thank you for doing this report. For those of you who have not yet read Emmy's report from the Center for Science and Emerging Technologies, that's CSET, it's Building the Tech Coalition, how Project Maven and the 18th Airborne Corps operationalize software and AI for the Department of Defense. You got to get a copy and take a read. We'll put the link in the show notes. Thank you both for being here today to share even more of your learnings, your lessons, and your wisdom with us. And we're looking forward to seeing where it goes from here. Joe and Emmy, we're looking forward to you capturing even more of these great lessons and cases for everyone to learn from. So thank you both for being with us.
Thanks, Noah.